Today, ladies and gents, we're going to start a new chapter, a unit, whichever way you want to look at it. Chapter 6 is Quadratic Equations. Now, we've been building up towards this using standard form, factoring equations, replacing numbers, substituting, doing all that fun stuff. And it's just going to get more fun from here. It's April 22nd of the year 2020. This is grade 10 math, but at any point if you're watching this, happy to have you. It's Mr. Benjamin here. Smiling. Big smiley face. Learning goals for this lesson. Identify the zero product property. Now, this is something we've done before. The first time you read it might not make sense, but the more you think about it, it's going to be like, yeah, of course, that's quite obvious. But many things in the math world kind of work that way, if I'm honest. So we're going to look at that, and we're going to see how we approach it and how we apply it. We're going to use a variety of methods to solve quadratic equations. Now, the more we see quadratics, the more they change and the more they kind of stay the same. We realize we can apply, again, the same principles towards them and new strategies whenever we need to. We're also going to convert a quadratic from standard to factored form. Now, we've done this before. We might have called it something different, but again, that idea is the same. Okay? So, the zero product principle. If the product, of course that's multiplication, so number multiplied by number, of any two numbers is 0, so if this equals 0, then at least one of the two numbers is 0. Okay? So, you can test that out. For any two numbers, when you multiply, let me do this in a different color because I've underlined that there. So, any two numbers multiplied together equals 0. Doesn't matter what this first number is, can be anything. This one has to be 0. So this first number could be 0, 1, 2, 3, 4, a million, whatever it is. The second number is always going to be 0. Okay? Why is that relevant? Well, first we want to recall some parabolic graphs. There's 3 different types we can have. Okay? We can have 2 zeros, which might look like this, might look like that, might look like this. Could be any one of those. I just didn't like how that one intersected. Can have 1 0, which might be touching there. Could be touching there. I know they don't look like they're touching, but I will say it's right there, okay? So believe me, they are touching. I'm actually just going to get rid of one of them and just have the one. Or we could have no zeros. There, 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 there. Obviously no zeros on this x-axis, right? When we consider factored form or factoring, if we try to solve, this zero product principle comes into play. Okay? So if we take this example, we have x plus 3, x subtract 1 equaling 0. We know that one of these two has to be 0. So what we can do is make them equal 0. X plus 3 equals 0. Also make this one, x minus 1 equals 0. Here, we're going to end up bringing this 3 over. X will be equal to negative 3. In this case, x will be equal to positive 1. Okay. That tells us what these values are to get 0. So that's where that zero product principle comes into play. If we were solving different types of equations, especially quadratics, anything with a parabola is quadratic, we have to keep in mind specific steps. So the first thing is going to be replace the y value with any given value. If we're looking for the zeros, we're going to try to find 0. We're going to plug that in, right? So in this case, we already have that. If it was, however, y is equal to 2x squared subtract 18, we would then change that y to a 0, which we've already done. Okay, so we're going to leave that. The next is to put it in standard form. If we recall, standard form is ax squared plus bx plus c equaling 0. This kind of already looks like it, right? There's nothing to rearrange. We don't have a b value here. B value would be right here. That might give you a hint as to how we're going to solve it, but for now, just keep that in mind. The third point is to factor if possible. I look at this, I have one variable, it's x, but I also have a 2, and I have 18, and I know 2 goes into both of those values. So 0 will equal 2 bracket x squared subtract 9. We're still in the factoring process, okay, so I'm not going to go to number 4 yet. If we can remember, in one of the previous lessons, we talked about the difference of squares. So if I look at this value here, x squared subtract 9. X squared is x squared, literally. 9 is 3 squared. Okay, since it's a difference of squares, what we're going to end up with, is 0 equaling 2 bracket x plus 3 and x subtract 3. Now we have values here that we can work with, just like in the previous equation. So x plus 3 equals 0 and x subtract 3 equals 0. Okay? Now we're going to set each factor to 0 and solve for x. X can be equal to negative 3 or x can be equal to positive 3. Those are my two values for x. Those are the two possible options. Looking at our next example, we're going to keep in mind these steps going forward, okay? So I have y squared is equal to 30, subtract 7y. First thing I see is that this isn't in standard form, so I'm going to try to put it into standard form, which, if we recall, ax squared plus bx plus c is equal to 0. Okay? So, if I wanted to rearrange this, where would each value go? X squared plus bx plus c is equal to 0. So I already have my y in here. Y squared equaling... No, I don't want the equal signs there. Subtract 7y. Subtract 7y. Plus 30 equals 0. Yeah, that looks pretty accurate. One thing I did, let me erase this and rewrite it. So, for consistency's sake, I do want to make this equal to 0 first, because that's our first step. So it's actually going to be 0 equaling, it's negative y, because it's going to come to the other side. Squared, subtract 7y plus 30. But don't worry about that negative, we'll get rid of it, because what we're going to do is factor out a negative 1 now. So basically this whole thing is going to be multiplied by negative 1. Okay? So 0 still equals negative 1, bracket, y squared, now it's plus 7y, because that value is going to change. For that sign and that sign is going to change. Subtract 30. Okay, now we have something here that we can work with. What we have is an a value equaling 1, and a b value and a c value here, so sum and product. Sum of 7 and product of negative 30. So we need to think of two values that work out here. So if we look at 30, 1 multiplied by 30, 2 multiplied by 15, 3 multiplied by 10, and 5 multiplied by 6. Pretty sure that's not going to work. That's not going to work. That's not going to work either. So we've got 3 and 10. All right. Now we need to get positive 7 and negative 30. Positive 7 is probably going to mean positive 10. Oops. And negative 3. If you add those together, you do get positive 7. If you multiply them together, you do get negative 30. So I'm fairly certain those are my two values. Alright? Now, we're going to write them out in our factored form. So, what do we have left with here? 0 equaling negative 1 multiplied by y subtract 3 and y plus 10. Alright? Now, again, we can work with this. We make each one of these equal 0. Y subtract 0 equals 3. Y would equal 3. And y plus 10 equals 0. Whoops. Sorry, I messed up that last one. Let me try that again. Y subtract 3 equals 0. Y is equal to 3. And here we've got y plus 10 equaling 0. So y is equal to negative 10. Alright? And those are our values. That's going to be our solved equation. Those are the two options we end up with. In this case, 2x squared plus 9x plus 4. It's already in standard form. I don't think we can factor. 2 doesn't go into 9, so we can't factor. And a in this case does not equal 1. So what we're going to have to do is we're going to have to multiply AC. So a multiplied by c is equal to 2 multiplied by 4, which equals 8. Okay, so 8 is our new product, and 9 is our sum. Alright, so sum 9, product 8. So we have to think of two numbers that add up to 9 and multiply together to give you 8. And I'm pretty sure they're both positive unless I've made a mistake here. they are. So, pretty sure it's just going to be 1 plus 9, 1 plus 8, and 1 multiplied by 8. So our two values are 1 and 8. Alright, so we will rewrite this 2x squared plus 1x plus 8x plus 4 equals 0. So now I look at these values here, and I'm going to have to factor. All right, what can I factor out of the first? I can factor x. X, 2x plus 1 plus, and in the second section, I can factor what, 4 out? Yeah, factor 4 out here. 2x plus 1. Now, you can see that I've got 2x plus 1 here, 2x plus 1 here, and x plus 4. So my new solution, or my new equation, is going to look like this. It's going to be 2x plus 1 multiplied by x plus 4. Now again, I have two brackets, or two functions, not functions, but two factors that I can work with here. I can make them equal 0. So I'm going to write it over here. 2x plus 1 equals 0. Bring the 1 to the other side. 2x is equal to negative 1. X is equal to negative 1/2. So that's one option. And I'm going to have this right here, x plus 4 equals 0. So bring the 4 over, x is equal to negative 4. So my two solutions are x is equal to negative 1/2 and x is equal to negative 4. So if I'm given a value, y is equal to negative 3. All right, so I have my equation. It's in standard form. Can I factor anything out of it? And even before, if I do that, I'm looking at it, really don't think I can. So all we're going to do is sub in y is equal to negative 3. What does that mean? There's our y. So negative 3 is equal to x squared, subtract 8x plus 12. Like terms, right? So I'm going to bring my negative 3 to the other side. So 0 is equal to x squared, subtract 8x plus 12 plus 3. Working that out, x squared, x plus 15. All right? Now I've got trinomial here. A is equal to 1. So that's okay. Sum, product. Sum negative 8. Product positive 15. This one jumps out to me really easily. Negative 3, negative 5. You multiply those together, you get positive, and when you add them, positive 15. When you add them, you get negative 8. All right, and we're going to write that out. 0 is equal to x subtract 3, x subtract 5. There you go. So, solving both of these, x subtract 3 equals 0. X is equal to positive 3. X subtract 5 equals 0. X is equal to positive 5. Now, if this was a graph, these would be our zeros, right? So, I'm going to have my little grid out here. One here, one here. We had a positive function, so our graph's going to open up. Now, if we look at the assigned value, y is equal to negative 3. Hold on just a second. Yeah, so that tells us at this point, negative 3, my x values are 3 and 5. So right there and right there. But those aren't actually my zeros, because if I go back to my original function, all right, keep in mind my original function is right here. This is when y is equal to negative 3. So if I were to find my zeros from here, I'd have product of 12, sum of negative 8. So that would be x subtract 2 and x subtract 6. Because these two values, when you multiply them together, you get positive 12. And when you add them together, negative 2 and 6, you get negative 8. So x would be equal to 2 and x would be equal to 6. These are my zeros. And that would be here and here. So it's going to be a little undignified, but let's try drawing that out. Hope that makes sense. So that's -3. Okay? That's 3 and 5. Of course, you're going to have word problems in many cases. So looking at this one. A ball is thrown from a cliff, period. Its height is measured with a function, h is equal to -5t squared plus 21t plus 120. That 120 is a constant, so that should automatically, this right here, constant, should give you an idea, it should give you some form of hint as to what's going on in the question, for example. I mean, the ball's being thrown off a cliff. That constant, maybe it should make sense. Height is also measured in meters, I should say that. Okay, so how tall is the cliff? Excuse me. This is the h-intercept, 120 meters. All right? How long will it take for the ball to fall 20 meters? So if it originally started at 120 meters, for it to drop to fall 20 meters, the height would be 100 meters. Fallen 20 meters, okay? So if we know that's the height we want, we can sub that in for h. Sub in for h to find t. Okay? Let's copy this equation. Let's put that right there. So what we want our h to be is 100 is equaling -5t squared plus 21t plus 120. So similar to, where's that example? We had an example just like this. The previous example right here, y was -3, we subbed it in. We have 100, we have 120 here. We're actually going to put the 100 on the other side. 0 is equal to -5t squared plus 21t plus 120 subtract 100. Alright, so we got 0, -5t squared plus 21t, and this is going to be plus 20. Okay, so now we have this value to work with. So a does not equal 0, a does not equal 1, so we need a and c. So 5 multiplied by 20 equals 100. So we have a sum, 21, product of, what did I just say, 100. So what two values, when multiplied together, give us 100, and when added together, give us 21. When I think of 100, I think of 10 multiplied by 10 and 5 multiplied by 4, or 25 multiplied by 4. I don't think it's going to be 10 and 10 because that would give us 20. 5 and 24, and we want positive. Is that going to work out? Let's see if we can work this out. So, if we've got, I don't think that works out. I think I made a mistake. Oh, here it is. Okay. So it should be -100. There you go. That'll work out now. So we'll have positive 25, -4. Okay. If we write this out now, 0 is equal to -5t squared plus 25t subtract 4t plus 20. Now I've got two functions that I can factor. I might need more space. I might go to the other page. Done. For some reason the circle came with, so let me erase that. I'm just going to move this up a bit. Alright, so what can I factor this out to? 0. I can definitely take out 5t, -5t even. -5t multiplied by t plus 5. Yep, that looks good. Oh, no, hold on. T subtract 5. Negative multiplied by negative gives you a positive. Yep, all right. And what can I remove here? Subtract. Can I factor out a 5 again? No, 4. I can factor out 4. Subtract 4. T plus, no, t minus 5. Yep. All right, so that's a good sign. We got t subtract 5 and t subtract 5 there. So 0 equals t subtract 5 multiplied by negative 5t subtract 4. All right, so I've taken that 5t and that 4, put them there. And then that t subtract 5 has been factored out. All right? Now, I've got two values that I need to solve for. So t subtract 5 equaling 0, and that t would equal 5. That's 5 seconds in the concept or of the question. Now this one's going to look a little weird. So I have negative 5t subtract 4 equaling 0. So negative 5t will equal 4. If I divide both of these by negative 5, I have t is equal to negative 4 over 5. So two weird things. 4 over 5 is 80% or 0.8 of a second. That's very quick. The other thing is negative time. Time cannot exist as a negative, at least based on our understanding of time. All right? And in fact, going forward in math, there's no such thing as negative time. So that's not possible. Okay? What we say is we're going to reject this answer. Because negative time, napa, doesn't happen. All right? So our answer must be t equals 5 seconds. So going back to the question, how long will it take to fall 20 meters? Therefore, sorry about that. It will take 5 seconds for, I'm going to get rid of this reject part, the ball to reach 20 meters. All right? So there's the answer to that question. Now we're at 23 minute mark, so we're going to end that here. I say thank you. If everyone's doing well, and have a wonderful day.